Hello ladies and gentlemen, and now we're going to take a look at some operations with radicals. We're going to start with adding and subtracting radicals. Here it says first simplify each radical by extracting all perfect square factors. So we're going to make them all into lowest simplest form. That's what that says. Then what we're going to do is we're going to combine like radicals by addition and subtraction. So back in the day when you guys were really young, we started off with if you have 2 apples, and if you add 3 apples and 1 watermelon, we were able to take the 2 apples and the 3 apples and say that we could have 5 apples and we would have 1 watermelon. Alright, and then when you got a little bit older, we said, okay, maybe we can do this with you. And we collected like terms, so we had 5x plus 1y. And now what we're going to do is we're going to give you 2 root 2's plus 3 root 2's plus 1 root 5. And we're going to ask you to combine like terms. And what you're going to get is you're going to look at the like terms. These are the like terms, so it's going to be 5 root 2's because they both have root 2's. So this is 2 root 2's plus 3 more root 2's is 5 root 2's and 1 root 5. Okay, so that's as hard as this is going to get today. So let's take a look. So looking at this one, I'm looking across. I have root 2, root 3, root 2, root 3, root 5. They are all in lowest reduced form. So I can add the ones together that go together. So I'm looking for like terms. I've got 3 root 2's and then I've got 6 more root 2's. So that means that I'm going to have 9 root 2's. I have negative 5 root 3's, and I have plus 2 root 3's, so that's going to be negative 3 root 3's, and I've got my watermelon sticking off to the side. He has no friends. Negative root 5 can't be added or subtracted with a root 3 or a root 2. They are not like terms. And you're done. Look at the next one. There's no like radicals, right? So we can't do anything with this. Wrong. Look up here. First, change all radicals to simplest mixed form to determine which are like radicals. They are in disguise. They're hiding on you. They're ninjas. So we're going to break them up. It's going to be 4 times 3 plus 9 times 2 plus 9 times 3 plus 4 times 2. That's what each one of these can break up into with its largest perfect square. So we know that the largest perfect square is going to come out, so it'll be 2 root 3's, and it'll be 3 root 2's, and it'll be 3 more root 3's, and it'll be a 2 root 2. And now we can look at like terms, and I've got a root 3 and a root 3, so that's going to be 1, 2, 3, 4, 5 root 3's. And I have a root 2 and a root 2, and it's going to be 5 root 2's. And notice this is my final answer, but if I wanted to, I could common factor out of 5, and I could make it look like this. And yes, you should be able to do that. That is something that I expect of you. Alright, well that was fun. Let's do it again. 4 root 3's, 2 root 20's, root 12. I got a feeling I've got some people hiding away in here, so we got to figure out where they are. Root 3 is already in simplest lowest terms. Root 20 is 10 times 2, but 10's not a perfect square. Let's see, it's 4 times 5. That'll work. 4 is a perfect square. 6 times 2, neither one of those are perfect square, but 4 times 3 is. And 6, 9 times 5. Now, watch. The difference between this question and the one above it is that I have some people sitting out in front of these radicals. So when this 4 comes out as a 2, it's going to bump into this 2. Okay, nothing comes out of here, so let's do that. This 4 comes out as a 2, it bumps into that 2, becomes a 4. Why does it become a 4? Because it's 2 times 2. This 2 comes out, there's no one sitting there, so it just sits there out in front. This 9 comes out as a 3, it's going to bump into the 6, and it's going to be 3 times 6, so it's going to be 18 root 5. If you don't believe me, think about this one. It would be 6 root 9 times root 5. So that's going to be 6, 3, root 5, and that's going to be 18 root 5. So basically I did all of this in my head to get that, and that's what I would like you to be able to do. Are we done? Heck no. we still have some some like terms. I got 4 root 3's minus 2 root 3's is root 2 root 3. I got 4 root 5's plus 18 root 5's. That's 22 root 5's. And just because I can, and because it's cool, let's common factor out of 2. It'll be root 3 plus 11 root 5's. And that'll be your final answer. So there you go. That's how we add and subtract radicals. Let's talk about multiplying. Now, I have to tell you, when you multiply radicals, the order of multiplication does not matter. So, what I'm going to do is I'm going to take a look at this, and this is what I see in my head. Do you see what I see? That's what I see in my head. Then, I know the order of multiplication doesn't matter, so I move it around. Then, I know it's 3 times 2 is 6, and I know it's square root 30, and then I give my final answer, which is 6 root 30. Okay, kids? Now, that's what I do in my head. What I do in reality is I look at the question and I say the 3 times the 2 is 6, the 5 times the 6 is 30. So what's outside the radicals multiply together, what's inside the radicals multiply together. Using that concept over here, I've got 2 times 5 is 10. I've got root 3 times root 6, that's going to be 18. And what I need to do is make sure that all my answers are in lowest mixed radical form. 18 has a perfect square that goes into it. It's 9. The 9 is going to come out as a 3. And it's going to leave us with 30 root 2. Notice we didn't do that over here because 30 does not have a perfect square that goes into it larger than 1. Okay, so there's nothing we can do with that. Only thing I can say here is also make sure that your indexes are the same. If the indexes were different, either up above with adding and subtracting or down below, then you can't do what we're doing, okay? They have to have the same index number. All of these have an index of 2. So root 2 times root 2 would be root 4, because 2 times 2 is 4, and root 4 is 2. So that would go pretty quick. The other way to think about that is that root 2 times root 2 is root 2 squared. Squared and square roots are opposite operations, and it'll leave you with 2. But this is the way you should probably think about it at the moment. Over here, it doesn't matter the number of terms that we multiply together. The order does not matter. So there's a 1 in front of here, so 1 times 2 times 5 is 10. 2 times 3 is 6, times 6 is 36. 36 itself is a perfect square. So 36 becomes 6, and we get 60. And that's all she wrote for how to multiply radicals, guys. So now I'm going to go on to dividing radicals, and that'll be a new video.